Alright, so in this video we are going to talk a little bit about C++. And so I'm going to start with a little bit of history. I always think it's fun to look into the history of anything we're studying, including languages. So Bjarne Stroustrup is the person who originally designed C++, and he did that in about 1985 at Bell Labs. And I'm going to talk a little bit about this, but it wasn't the first object-oriented language, but it was the first one that became like somewhat mainstream or popular. And one of the quotes that I like from Stroustrup is, "C++ is a general-purpose programming language designed to make programming more enjoyable for the serious programmer." I don't know that everyone would agree that C++ is enjoyable. It is a difficult language. It's a really big language, and it's definitely not everyone's favorite. There's some people that say like you could never be an expert in C++. Some people say like whenever they couldn't decide on a choice in C++, they just decided to do all of the options. But one of the things that is so interesting about C++ is that it did evolve from C. So if you want to know a little bit about the history, C was designed by in around 1972, and so as you know, C is not object-oriented, or maybe you don't know that, but it's a procedural language, and we're going to talk a little bit about the difference between the two and how they interact, because C++ did evolve from C, so it does bring with it a lot of what C can do. But the first object-oriented programming language was Simuli, which was in 1967. And so it was the first one that kind of introduced the concept of these abstract data types that I talked about in the previous video, and then also, this object-oriented, like kind of turning programming on its head. And it was the one that determined much of the terminology that we're going to be using in this class with C++ and the objects. After that came Smalltalk, which was developed at Xerox in the 1970s. And that was the first one to gain a lot of attention, but it didn't get much commercial success. But it did make a lot of programming more accessible to a wider audience, much more than C did. And so C++ was one of the many variants of C that was kind of designed. A lot of them were designed at like a similar time. And I forget what they're all called. I didn't write it down, but they're like B, just a bunch of like letters. But they caught on because they all had C still contained in them, and C++ did as well. And so it was kind of one of the first most successful object-oriented programming languages. Now C and C++ are in love, as you can see from this picture that I definitely drew. They both have their purpose and their worlds, and so we're going to talk a lot about all the things we love about C++ and all the things that are better about it than C, but they really are two different things. Object-oriented programming doesn't trump procedural programming. They both have, they're both needed. And so we're now gonna, spend the next couple of videos going through and talking about what you need to know about C++ with like the general assumption that you've spent a little bit more time in C, because so many of you come from 107 and 141. C++ is a unique language in where it falls. Some of the stuff you might not have heard about before, and that's okay. It would be great if you came back to this slide at the end of the semester and you're like, oh yeah, I know what that is. But basically, object-oriented languages in particular have different ways of managing memory. And in C++, it's all yours. You manage it all. So that's the deterministic resource management bubble. And generally. And then another option is a garbage collector, which is what Java has, where basically it takes care of all the memory cleanup for you. So we're going to spend a lot of time talking about that in this class because you are going to be responsible for managing the memory, and that's why we're going to learn Valgrind to help us make sure that we're doing that cleanly. Static and dynamic is referring to just the types being assumed or interpreted at compile time. And so C++ is compiled, so everything is figured out during the compile time, not during runtime. And so it falls right in between those three, and that makes it definitely a unique and fun language to get to play around with. Another quote from Strostrop is, "A lightweight abstraction programming language designed for building and using efficient and elegant abstractions." And I love this quote because it's basically what our class is. We're going to be really designing abstractions with data structures and using abstractions and really thinking about problem solving with abstractions. And that's why C++ is such a great language for that. So some of the things that we talked about today is that C++ is more modern, more powerful, and it's object-oriented. You have the ability to use C within your code, and we will use it for all of the low-level implementation of our data structures. It's the only way when you're designing classes. But anytime it's possible, you're going to want to stay high level. So for project 1, and we'll talk about this a couple different times, you should not be using C strings or any of the kind of C features that you might be used to. You should be using the higher stuff like the string libraries and the string class. Streams, stuff like that. So we're going to talk about that a lot. But C is not gone. We're going to need it to do, when I drew all those pictures of all those different data structures with linked lists and trees and graphs and arrays, those are all going to be done in C with pointers basically and arrays. So as an example, it's kind of like in memory of arrays in C, what you might have seen before or might be used to, and if you're not, that's something you're going to want to review for sure because we're going to be using them. You can set up arrays in C on the stack here or on the heap and manage the memory. Access is done with the square brackets. And then in C++, you have the vector class, and so the vector class allows you to set up these objects which are vectors, push things into them. You don't need to decide how big to make the vector like you do in C over here. It's all managed under the hood of the abstraction of the vector class. If you want to, print to console in C, use printf. So now that you're in C++, you're going to use all of the streams, which we're going to cover this week, like cout. You'll notice that the abstraction of the vector class actually mimics what the C class does, because that's what the designers of C++ wanted. They wanted it to look like an array, but it's not. It's a vector that abstracts the functionality of an array, but makes it much easier to use. So this is the kind of stuff that we're going to be talking about. Some of it's probably things you've already thought about a lot, but maybe just haven't spent the time to put the right terminology to it. That is it, I think. Oh no, one more thing. One of your best friends this semester is going to just be becoming familiar with the C++ standard library, so you can get to it easiest by just searching the library. So just in Google, just search C++ vector, and the first thing that will pop up is the documentation and that library. And this is like a picture from Wikipedia of like I think the actual first draft of it or something on the standard library. But what's so cool about C++ is that it does come with all of these containers that we get to use. So we're going to spend the first couple of weeks getting familiar with the standard containers. C++, again, tried to make like everything possible, so some of the syntax is like kind of clunky. It's not super elegant, and so there's always going to be these little things that we're going to have to learn that are like perhaps not obvious or not the way you would design them. But the great news with C++ is if you hate the way something is designed, you can just design it yourself in the way that you would like to use it for an abstraction. So that's all I have for this video. Thank you all so much, and see you later.